In digital image processing, let us see image restoration. Image restoration, the name itself suggests that we have a degraded image. Okay, so we model that how this degraded image might have been the earlier image. Okay, the good image, how it would have been. So we model like this so that we can retrieve the actual image. This is the image restoration. So what is meant by image restoration? Restoration attempts to reconstruct or recover an image that has been degraded by using a clear knowledge of degrading phenomena. So if we are aware of degrading phenomena, then we'll apply. If we are not aware of degrading phenomena, we'll model it. So restoration, as the name suggests itself, that it is reconstructing or recovering an image that has been degraded by certain phenomena. What are the two properties in linear operator? There are two properties in linear operator because we are going to use it in these situations. Additivity and homogeneity. Explain additivity, this first one, property in linear operator. See, if this, let me tell you first. The additive property says that if this is a linear operator, the response to the sum of 2 is equal to the sum of response or sum of the two responses. That means if you take linear operator of f1 and add it with the operation of linear operator on the f2 and you combine it, then it will be equal to just add them and then combine the linear operator. This is the additivity. How a degradation process is modeled. So in this we'll see that in the beginning what I said, I'll explain it more now. So what we are doing here is we have fxy, that is our image. Now we have a system operator called h, which together with the additive white noise or additive noise, which is eta xy, it operates on the input image fxy to produce our degraded image gxy. So how we have modeled it, that we are aware that original image is this. This is the degraded image. This is the noise which has come. It has added somewhere. So now when we have this image, we can model the reverse and get the image. This is the modeling of degradation process. Now explain the homogeneity property in linear operator. We said that linear operator has two property. Additivity that we have seen. Now homogeneity property. This is the homogeneity property. The homogeneity property, it says that the response to a constant multiple, this is a constant multiple k1. The response to a constant multiple of any input is equal to the response to the input multiplied by the same constant. If you have f1 xy, multiply it with k1 and then take the h, that is the linear operator, apply linear operator on the multiplication of this k1 with fxy, this is the image. This is equal to, first you take the linear operation and then multiply it with k1. Give the relation for degradation model for continuous function. This is the relation gxy is equal to minus infinity to infinity f alpha beta, and here we have delta of x minus alpha and y minus beta, delta d alpha d beta, and this is eta xy. This eta xy is what? This is the noise. So this is the relation of degradation model for continuous function. Minus infinity to infinity make it continuous. Now what is a fredholm integral of first kind? This is the what we have just seen. So this is the fredholm integral of first kind, which is called the superposition or convolution, or we can easily say it as a fredholm integral. Superposition and convolution is the fredholm integral of first kind. So it states that if the response of h to an impulse is known, the response of any alpha beta f alpha beta can be calculated by means of fredholm integral. This is the expression which we are going to use. We can compute gxy using this, and you can compute f alpha beta by inverse of this. What is the concept of algebraic approach? The concept of algebraic approach is to estimate the original image, which minimizes a predefined criterion of performances. What are the two methods of algebraic approach? One is the both are restoration approach. One is the unconstrained restoration approach. The other is constrained restoration approach. Define the gray level interpolation. Gray level interpolation deals with the assignment of gray levels. Gray levels are nothing but the intensity value or digital numbers. So gray level interpolation deals with the assignment of these gray levels to pixels in the spatially transformed image. If you have one image, you have transformed it You have dn values. Now you have to give dn values to the transform image also. This is the grade level interpolation. Next is what is meant by noise probability density function, noise PDF. The spatial noise descriptor is the statistical behavior of gray level values in the noise component of the model. This is the meaning of noise probability PDF. What is geometric transformation? Transformation which is used to alter coordinate description of an image. So we have certain geometric transformation which we say that we are altering the coordinate description of the image. This is mainly three. In 3D also, computer graphics also you see this. Image translation, scaling and image rotation. So translation, scaling and rotation, these are the three fundamental geometric transformation. What is image translation and scaling? See, if you have image, you want to take it somewhere else. This is the translation. Now you want to increase the size or decrease the size. Image translation means repositioning the image from one coordinate location to another along straight line path. And scaling is used to alter the size of the object or image. We have seen how we can shrink and grow the object or image. That is, a coordinate system is scaled by a certain factor. Why the restoration is called an unconstrained restoration? The restoration is called as unconstrained restoration because in the absence of any knowledge about the noise, that is eta, a meaningful criteria function is to seek this f cap such that this h, or linear operator on f cap, approximate of in a least squared sense by assuming that the noise term is as small as possible, where h is the system operator, this one, and this f cap is the estimated input image, and g is of course the degraded image. What or which is the most frequent method to overcome the difficulty to formulate the spatial relocation of pixels? The point is the most frequent method, which are subsets of pixels whose location in the input, that is the distorted, and output, that is the corrected image, is known precisely. What are three methods of estimating the degradation function? So first is observation, second is experimentation, and third is mathematical modeling. So these are the three methods for estimating the degradation function. The simplest approach to restoration is direct inverse filtering. So an estimate, that is f cap of uv of the transform of the image, simply we can divide the transform of the degraded image, that is g, by the degradation function. So f will be g by h. This is the simplest approach. What is pseudo inverse filter? It is the stabilized version of the inverse filter. For a linear shift invariant system with frequency response say h, the pseudo inverse filter will be given by 1 by hv, where h is not equal to this should not be 0, and if h is equal to 0, 0. Okay. What is meant by the least mean square filter or Wiener filter? Wiener filter. The limitation of inverse and pseudo inverse filter is very sensitive to the noise. So the Wiener filter is a method of restoring images in the presence of blur as well as the noise, because it is not going to, the sensitivity is not there, not that much. What is meant by blind image restoration? Blind image restoration. And information about the degradation must be extracted from the observed image, either explicitly or implicitly. So this task is known as the blind image restoration. What are the two approaches for blind image restoration? As we just knew that an information about the degradation must be extracted from the observed image, maybe explicitly or implicitly. So approaches for blind image restoration is direct measurement and indirect estimation. What is meant by direct measurement then? In direct measurement, the blur impulse response and noise levels are first estimated from an observed image, and this parameter is utilized in the restoration. What is blur impulse responses and noise levels? First is blur impulse response. So this is a parameter which is used, or this is measured by isolating an image of a suspected object within a picture. While the noise levels, the noise of an observed image can be estimated by measuring the image covariance over a region of constant background luminance. What is meant by indirect estimation? Indirect estimation. The indirect estimation method employs temporal and spatial averaging to either obtain a restoration or to obtain key elements of an image restoration algorithm. Give the difference between the enhancement and restoration. We have seen the enhancement in the earlier discussion, and now we are knowing the restoration. So estimation technique is based primarily on the pleasing aspect, viewing aspect, it should look good. It might present to the viewer. That is, it should be pleasing or worthwhile for the viewer. For example, you stretch the contrast or enhance the contrast. While the removal of image blur by applying the de-blurring function, this is considered to be a restoration technique. So obtaining the image from the degraded image, this is the restoration technique. What do you mean by point processing? Image enhancement at any point in any image depends solely on the gray level at the point, which is often referred to as the point processing. One by one pixel wise processing. What is image negatives? The negative of an image, let's say gray level 0 to L-1, is obtained by how you can get it? By the negative transformation, which is given by L-1 minus R, where S is the output, that is the image negative, and R is the input pixel. So the highest value, if this is the highest value, say 255 is the highest value. So we subtract each value of pixels from 255 and we'll get the image negative. Give the formula of negative and log transformation. This is the negative which we have just saw, and this is the log transformation. S is equal to C log 1 plus R, and R, as you know, this is the input pixel, and C is the constant, which is greater than equal to 0. So S is equal to C log 1 plus R. This is the log transformation. This is the negative of the image. What is meant by bit plane slicing? Bit plane slicing. So instead of highlighting gray level ranges, highlighting the contribution made to total image appearance by specific bits might be desired. We have already seen what is gray level highlighting. So the highlighting the contribution which is made to the total image appearance by specific bits, this may also be an option. Suppose that each pixel in an image is represented by 8 bits. So imagine that the image is composed of 8 1-bit planes, because represented by each pixel is represented by 8 bits. So just consider that you have 8 planes, and ranging from bit plane 0 to LSB to bit plane 7 for MSB. This is the bit plane slicing, different planes. Why blur is to be removed from images? Blur is caused by the lens, which is taking the picture. That is, say, in improper manner, relative motion between camera and scene and atmospheric turbulence. So it will introduce bandwidth reduction and make the image analysis as complex. So to prevent these issues, blur is removed from the images. What is Lagrange's multiplier and where it is used? Lagrange's multiplier. The Lagrange multiplier is a strategy for finding the local minima and maxima of a function subject to equality constraints. This is mainly used in the image restoration process, like image acquisition, image storage, and transmission. Compare the constrained and unconstrained restoration. Constrained and unconstrained restoration. Let us see the constrained one first. In the absence of any knowledge about the noise, based on, say, Lagrange multiplier and linear operator, a meaningful criteria function to seek the f cap such that h of f cap approximates of in a least square sense by assuming that the noise term is as small as possible, where this h is a system operator, f is the estimated image, and g will be the degraded image. But in this case, unconstrained restoration, again in the absence of any knowledge about the noise, a meaningful criteria function is to seek f cap such that h of cap approximates of in a least square sense by assuming the noise term is as small as possible. Okay, here we are talking about Lagrange multiplier and the linear operator. So here we have h as the system operator, again f cap is the estimated input and degraded image. So here things are constrained, here things are unconstrained. What is the principle of inverse filtering? Inverse filtering is given by f cap is given by GUV by HUV. So f cap is the restored image, GUV is the degraded image, and HUV is the filter transfer function. So inverse filtering is given by this function. Define rubber sheet transformation. Geometric transformation may be viewed as the process of printing an image on a rubber sheet and then stretching the sheet according to some predefined set of rules. So therefore they are called as rubber sheet transformation. So this is about image restoration. Next we'll be taking image segmentation. Till then, thank you so much. Take care.